Hi everybody, here's Lucy's class. Today we are going to talk about projectile motion and relative velocity. We have two examples for each one. A rescue plane wants to drop supplies to isolated mountain climbers on a rocky ridge 235 meters below. If the plane is traveling horizontally with a speed of 250 km per hour, A. How far in advance of the recipients must the goods be dropped? B. Suppose, instead, that the plane releases the supplies a horizontal distance of 425 meters in advance of the mountain climbers. What vertical velocity, up or down, should the supplies be given so that they arrive precisely at the climber's position? C. With what speed do the supplies land in the latter case? Okay, let's solve problem A first. In order to let the goods drop down exactly at the mountain, we should know the correct distance to drop it down. That means we should know the time to drop the goods down first. As we all know, the time to drop down this way is totally same like this way. So we first calculate the time to drop it down directly. Then we can use this formula. Suppose there is 235 meters. There is 0 meters. Then we can get because Vy0 is 0. That's because the plane was flying horizontally before the goods was dropped down. And this part is 0. And minus this. Then by calculating this one, we can get the t. T equals to 0.925 seconds. This is the time to drop it down. After this, we can use x because the x0 is 0. We could get Vx0. In the problem, it is 69.4 meter per second times 0.925 seconds. The result is 480.613 meters. Then this is the answer of X. Let's do question B now. This time the X is stipulated as 425 meters. As a result, if we still let the goods drop down freely, it will be away from the mountain. That's so bad. So we must give the goods a force to let it drop exactly at the mountain. So we have a Vy0, and this is less than 0. In order to know the magnitude of Vy0, we can still use this formula. Yeah, this time the Vy0 is not equals to 0. But we don't know t. However, we can know t from other formula. Because the plane is flying horizontally and with a constant speed of 69.4 meters per second. So we can know t from this. X equals to Vx0t. T equals to this one. And t is equals to 6.1239 seconds. And then we can calculate this. The result of Vy0 is minus 8.366 meters per second. Then this is the Vy0 we want. In question 3, we are asked what the speed do the splice land in the mountain. Figure out what do we know. We know Vy0, we know A, we know Y, Y0. So we can use this formula. Put the numbers we know in it, and it is after calculating, we know the result of Vy equals to 68.53 meters per second. That's the final answer we get. Question 2. A shot putter throws the shot with an initial speed of 15.5 meters per second at a 34-degree angle to the horizontal. Calculate the horizontal distance traveled by the shot if it leaves the athlete's hand at a height of 2.20 meters above the ground. Let's solve question 2. In order to solve this, we can divide this parabola to two parts. We should know this part. The ball used to cross this part first. We know it is a parabola, and we can use the formula of T total equals to 2 Vi sine sigma over G. We know the Vi, we know the sine sigma, we know G, so we can know the answer of T total. We use T1 to represent T total. That's the time of this part. It is then we deal with this part. This part, just like a ball was thrown down, but it's with initial velocity. Then we can use this formula. What is VOY? His initial velocity, we don't know that, but we can get it because the parabola is a symmetry figure. So the velocity at this point is totally same at this point. If we know the velocity of this, we know this. We have an angle, we have a velocity, then we can solve it. Here's a triangle. The VOY is equals to VI times sine 34 degree is 8.667 meter per second. Then we put it back to there. The T2, this is T2, equals to 1.994 seconds. But what we should know is x. X is equals to Vt, right? The V is the part we don't know, but we know the ball thrown the horizontally, the V is constant, is Vox, and we can know it from there. The Vox is equals to Vi times cosine 34 degree. And we know it is 12.85 meter per second. Then the x t there is t1 plus t2. The x is equals to 48.35 meter. This is our correct answer. An airplane whose airspeed is 620 kilometers per hour is supposed to fly in a straight path 35 degrees north of east, but a steady 95 km per hour wind is blowing from the north. In what direction should the plane head? Ligature these 2 points, we know the airplane still heads to this direction. And we should know this. Suppose the angle of it is sigma. In order to know the magnitude of sigma, we must put it in a triangle. Let's have a model. We have an angle is 35 degrees. We have a number is 620. As a result, we can know AC and BC. That's amazing. Then we can calculate CD. CD equals to BC minus BD, which is 95. Then CD is equals to now we know CD, we know AC, we know tangent sigma. By using our calculator, we can get the magnitude of sigma. .16 degree. This is our answer. An unmarked police car traveling a constant 95 km per hour is passed by a speeder traveling 145 km per hour. Precisely 1 second after the speeder passes, the policeman steps on the accelerator. If the police car's acceleration is 2 meters per second square, how much time elapses after the police car is passed until it overtakes the speeder? Situation: suppose the police car is black and the speeder is blue. We can draw that this is a police car and the speeder passes it. And the police car decided to accelerate. In this process, there the speeder passes it. There the police car decided to accelerate. There they meet. Now let's do some preparing work. That to convert units, we have 95 km per hour and 145 km per hour. We should convert it to meter per seconds. And the result is 26.389, 40.278 meter per second. We know if the police car decided to catch the speeder, its final speed must greater than the speeder's speed, which is 40. So we can infer that in this process there must be a point that the police car speed is equals to 40.2. The v is equals to v0 plus at. We know a, which is 2 meters per second square. We know v0, which is 26. Then the v is 40. So we can get the t. The t equals to 6.945 seconds. But to have the same speed is not our purpose. We must let the police car have a greater speed than the speeder. Then we can draw another picture that when they have a same speed, and this instant, and there they meet. And there, the distance between them with it is the distance at the 1 second. The delta distance is equals to delta v times 1s. The delta v is the difference between their speed. And finally, we can get the answer that delta d equals to 13.889 meter. And this part, they are same. So we have the formula, we usually use it, that is x equals to x0 plus v0t plus half squared. And the x is 13.889 plus the 40.278 meter per second times t. This is with its constant speed, the distance that it moves. So the x is from there to there. The x0 is 0. The v0 is also 40.278 because at this instant the police car have the same speed with the speeder. The t plus t squared, because this is 2 meter per s2, and this is 1. By solving this, we can get it t equals to 3.723 seconds. This is t2, and we have t1 and the t total equals to t1 plus t2 equals to 10.672 seconds. Then this is the answer we want. That's all. Thanks for watching.